Are you still running SQL Server on premises? Well, if you are, or if you're starting new, this is for you. We're sharing how to modernize your SQL Server workloads so you can eliminate infrastructure management, avoid end-of-support disruptions, and move to always up-to-date, high-performant cloud-native solutions with Azure SQL Database Hyperscale. And because it runs on Azure infrastructure, including AMD EPYC processors, you benefit from the latest innovation automatically without managing the hardware yourself. Migrating to Hyperscale isn't a full application rewrite. You're going to take your existing SQL database and move it to a managed environment where you get built-in high performance, up to 4.5 nines of availability, and the scaling your application needs on day 1 and day 1,000. Because it's the same SQL engine and the same T-SQL surface, there are minimal compatibility surprises. Bob, you've seen a lot of migrations. What's kind of the common scenarios that you see for how people actually do this?
Well, thanks, Anna. There are many different ways to migrate into Azure SQL depending on your target. But the most common path into Hyperscale is using Azure Database Migration Service. It's a guided workflow that handles all the core steps: assessing your database, migrating your schema, migrating your data, and getting ready to run it in Azure. For many workloads, this is the fastest and most straightforward way to get started. Okay, so Anna, when I've built a migration using Azure Database Migration Service, I built an architecture like this. On the left-hand side is, in this particular case, SQL Server 2019 running our database. I install some components. That's like phase 1. I'm setting things up. I install like the Azure Database Migration CLI, something called the Self-Hosted Integration Runtime. These are software components that are going to help coordinate things on the client side in the host. On Azure, I deploy an Azure Database Migration Service and a logical server along with Azure SQL Hyperscale. And you can see below here, they're kind of like the 5 phases that I would normally use to do this migration. What's interesting is when I built this solution, I used GitHub Copilot in Visual Studio Code along with a skill that I built so that we can do prompts, and that'll direct us to the right set of scripts to go do the actual migration. So given that I've done some of these steps, the first thing I'm going to do is do an assessment. You can see I'm going to use a prompt here. This prompt is going to run a particular PowerShell script that is going to coordinate with CLIs to perform this assessment. It's an offline assessment, actually. It's going to look at things in the database that could be blockers for us to do an actual migration. Now, look at these results here. The only thing that we've found in our database is the fact that a feature called Service Broker has been enabled in our SQL 19 database. That's a default. Any SQL Server database has that default, but that's okay. We're only enabling that feature. We're not actually using it. So we're just giving a warning to the user that, hey, Service Broker is not supported in Azure SQL Database. So in case you were thinking about using that, that could be an issue, but it won't actually block our actual migration. So that's the assessment phase. Now I've deployed Hyperscale. So what I'd like to do now is go through and do an actual migration of my schema. This is where we're going to use the Database Migration CLI, which is going to use DACFX to look at the source schema inside SQL Server and migrate that using SQL scripts all into our target Hyperscale database. And you can see here, the prompt is led to a PowerShell script that I wrote, which is going to perform all of these steps for us. So I'm going to go ahead here and approve from the prompt that it can go ahead and do the actual schema migration. And this is going to run a set of scripts on the source side to read those objects that need to be migrated, and then to go ahead and migrate on the target. So I'm going to put in a password on my source to do the migration. And you can see here I get progress along the way of how this is actually working. Now, what I love about Visual Studio Code and the MS SQL extension is that it has schema compare. So I can go here and click on the source database in SQL 19 and say, hey, let's compare our schemas. So I'll choose the source SQL 19 server, in this particular case, SQL 19 with my database, Saba Lending, and the target being Azure SQL Hyperscale. Remember, I've deployed that database there. The schema's been migrated. So what I hope the tool is going to show me are there any issues that I had when I actually migrated the schema. I'll simply run compare inside the tool, and it'll show me are there any issues it found. What's interesting here is it did find some differences, but these can be ignored, because these are roles or security roles inside SQL 19 that are not required for me to run in Azure SQL Hyperscale. So I successfully now migrated my schema. My objects all exist in my target. What I want to do now is go migrate my data. But since I built a skill and a set of PowerShell scripts, I can use a prompt like this. The appropriate scripts will be selected using the skill run book by GitHub Copilot, using our model here, and it can go through and decide how do I go do this migration? How am I going to connect to a SQL 19 database and migrate my data on top of the schema I already have? So you can see here, it's going to prompt me now, run this particular PowerShell script, and then go through and prompt me for passwords. I need a password connect to the Hyperscale database, which I'll put in here as well. And then in this particular case, the self-hosted runtime that I installed is going to be that data plane. So it has a user as well that's been provisioned in SQL 19. I need to put in the password for that as well. With this in place, the self-hosted runtime will connect to SQL 19 data source, take data, orchestrated through DMS, and copy that now into Hyperscale. Now, this could take a few minutes for sure to run depending on the size of your data. What I love about this process is I do get progress status reports if I'm looking at my terminal here. And right now, I'm only seeing the beginning of things. Like this is the beginning of the migration process. I'm not seeing any tables show up. What I hope to shortly see is like a per table progress, and you can see it's starting to show up. It's showing me the phases of copying rows of data on a per table basis. And a few minutes later, at some point, it'll be finished. And you can see now it's successfully migrated our data, and it gives me, what I really love here is row counts per table. So I can kind of look at that and see, does this look right? Does this look like the rows that I had in my source showing in my target? Now, for me, I want to make sure it's fully validated. So I built another skill that will actually connect to SQL 19 and connect to Azure SQL Hyperscale and do simple row counts so that I can see that the row counts that were actually in the table in SQL 19 show up exactly the same way in Azure SQL Hyperscale. So by putting in my password in, the PowerShell script can go run queries against both, come back and tell me, yeah, indeed, everything lines up. Total number of rows and rows per table have been actually migrated. So Anna, you can see I did all these phases. I did it all inside Visual Studio Code. I installed the tools. I used a set of skills that guided the right PowerShell scripts to do the complete migration process for me.
Awesome. Thanks, Bob. And the key takeaway is that modernizing your SQL workloads to Hyperscale doesn't require that full rewrite. You can migrate existing workloads using a guided path like the one you saw from Bob. You can get it up and running quickly and then optimize over time. That gives you a practical way to move into Hyperscale while improving the way your applications perform, scale, and operate in the cloud. Thanks for watching. Check the link below for more information.